All right, John. So we're going to skip ahead to section 4.5 on isosceles and equilateral triangles, only because Delta Math has some really cool angle problems that involve the isosceles triangle theorem, which we'll talk about in a second. Okay, so these are special types of triangles. The third type of triangle to really talk about is a scalene triangle, and in a scalene triangle, let me write that word down. In a scalene triangle, you have no congruent sides. So scalene means you have no congruent sides. So all three sides are of different length. That's scalene. So then we're going to talk about isosceles and equilateral in this section. So first, what is an isosceles triangle? Well, it's pretty common, right? So an isosceles triangle, you typically have two congruent sides, right? So we call them the legs, okay? And then you have a third side that's called the base. The angle in between the congruent legs is called the vertex angle. And then the two angles that touch the base are called the base angles, all right? So again, two congruent sides is the most important thing, right? Two congruent sides. So I'll write that up here. So isosceles, isos means two congruent sides. Keep that in mind. Okay? All right, but now we have this thing called the isosceles triangle theorem. Very, very, very important theorem to remember. We usually use this a lot. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So again, basically it says if you're an isosceles triangle, then you have two angles congruent. Now, the important thing is that these angles opposite those sides that are congruent are called the base angles. The base angles are congruent. That's what you need to remember, right? So in this picture here, side AC and BC are the congruent sides, right? That means AB is the base. So that means that angle A and angle B, the two angles on the base, are the congruent angles. Okay, so be aware of that. So again, instead of calling it the isosceles triangle theorem, some people call it the base angles theorem. So depending on your book, this might be called the base angles theorem. Okay? All right, cool beans. So now, the converse of this is also true. So there's the converse of the isosceles triangle theorem. So we just take the isosceles triangle theorem and switch the hypothesis and conclusion. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So again, if this is your picture, two congruent triangles, that makes side AB the base because these are the two congruent base angles. Therefore, the legs would have to be AC and BC, and they're congruent. Okay, so again, it's just the order, right? And if we wanted to, we could write it biconditional because the conditional and the converse are both true. Oh, sorry, hold on just a second. Okay, hope that doesn't make my video go too long. All right, and now we have these things called corollaries, right? Last slide here. So a corollary is a theorem that can be proved easily using another theorem. And again, I don't care about that so much as the ideas here. So we have two corollaries. The first one says, if a triangle is equilateral, then the triangle is equiangular. So what in the world does equilateral mean? Well, it means equal sides. This lateral idea is side length-ish. You know, that's what it kind of means. And equal means equal. So you have a triangle with all three sides congruent. If that is true, then it's also equiangular, which means all three angles are congruent. Now, let's see if we can do one better, right? Can you tell me the actual angle measures in this triangle? Well, we learned in last section that the sum is 180, right? And if all three are the same, why don't we just take 180 and divide by 3? And what do you get? You get 60 degrees. And each angle in an equilateral triangle is 60 degrees. Now, this idea down here, if a triangle is equiangular, then the triangle is equilateral. This is just the converse to the one above. This is the converse to this theorem up here, right? We just switched equiangular and equilateral. So again, if you know that all your angles are congruent, if you know that the three angles are each 60 degrees, then you know that this triangle has three congruent sides. Great. Okay, so there's our special kind of triangles to talk about. Now let's do a couple problems.